All right, today we're going to remind ourselves of composite functions. So we're going to start with stuff we did last year, and then we're going to apply it to some of the harder stuff we've been doing this year. Yes, I would like to make someone cry today. All right. So remember this, y equals something or other is the same thing as f of x equals, right? The function of x is going to be, I'm going to say this is 3x minus 4. Remember, if I have multiple functions, I need different letters to show that they are different things. So the next function I'm going to call g of x. All right, so we usually start with f. You can start with a. We normally start with f and then just go down the alphabet. Okay, guys, let's not talk while I'm talking. We just go down the alphabet from here. That's just the agreed upon thing. It doesn't really happen for a reason though, right? So I'm going to call this 10. That does not look like a 0. Let's try that again. 10x plus 1. All right, so there are multiple ways that I can put this stuff together. So if I want to find fg of x, remember what this means is I take f and instead of my variable, I put in the whole function of g. So whichever letter comes first, that's the function you use, and you replace the variable with the second function. So that means I get 3, and instead of x, I've got 10x plus 1, and then I've still got my minus 4. Yeah? So then I'm going to distribute. So then I get 30x plus 3 minus 4. So then this is 30x minus 1. So this is the function, the composite function f of g, or fg of x, sorry. All right, now I can do this the other way around and I will get a different function. If I want gf of x, I'm going to start with g and instead of the variable, I'm going to plug in all of f. So I can have 10 and instead of x, I've got 3x minus 4 and I've still got my plus 1. So again, I'm going to distribute. I get 30x minus 40 plus 1, which gives me 30x minus 39. Do we remember this stuff? Okay, so composite functions. There are also things that you can do like fg of 2. So instead of x, I'm just going to substitute in 2. So I've already done f of g. So I'm just going to replace x with 2, which gives me 60 minus 1, which is 59. And I can do the same thing down here. Let's say that I'll leave that. Let's say that I want gf of negative 1. Well, all I do is put that in there. 30 times negative 1 minus 39 is negative 30 minus 39, which is negative 69. All right. So you can do composite functions in terms of x, or you can get actual numerical answers if you're asked to substitute in a value for x. We remember that stuff? None of that's new, okay? All of that's just from last year. I promise you it was. There's one, actually, I might do one more thing on this page before I get rid of it. Let's pick another color. I can do, let's just zoom out for a second so I've got some more room. I can also do something like f of x. You can put a function inside itself. So I've got 3, and instead of x, I'm going to put the whole function in there, and then I've still got minus 4. Right, so you can put something inside itself, which feels like cannibalism, but anyway. So we've got 9x minus 12 minus 4, 9x minus 16, okay? Yeah. Inverse. We're not doing inverses today. We will cover them soon, though. We will also be doing inverse functions soon. Actually, yeah, let's not bother going through any of that. All right. Let's now make it a bit harder. All right, I'm going to do some of the questions in the book that I have not assigned you. All right, let's go back in. All right, this is question 1b. I have not asked you to do this. This one says that f of x equals x squared plus 6 and g of x equals x plus 3 all square rooted minus 2. Sorry? 1b.
You did all of them.
That's very disappointing.
Yeah.
Oh, I looked at the wrong thing. All right, I'm not going to do this. What haven't I asked you to do?
Question 2, 4, 6.
Oh, let me have a look at 2.
Okay. Well,
Maybe I meant to do 2 and I've accidentally done 1b. You know what? How about I do 1b later? I can do this later. What about 2? H and K. X is such that. Oh, that's really easy. Okay, I'm going to come back and do this one later. I'll get rid of that for now, and I'll come back and do it later. All right, I'm going to do question 4 in that case. All right, this is question 4. So I'm going to use different notation just so that you get used to it again. So F is such that X is, remember, you can see little things like this, 2x plus 3, right? This is the same thing as saying F of X is that, just different notation. And then G is such that X behaves like 12 over 1 minus X. All right, so there are 2 parts to this question. The first one, what does it ask me to do? The first one asks me to find GF of X. Okay, so A is asking for GF of X. So I'm going to put F inside of G. So it looks like this. I have 12 over 1 minus, and instead of X, I'm using F. So it is 2X plus 3. Do I need these brackets?
Yeah.
Why? Good, I need the brackets because this negative is going to distribute to both of these parts. Some of you are still making this mistake. Multiple people made this mistake on the test this week. It's really important that you watch your signs. So that means that 12 over 1 minus 2x minus 3 is 12 over negative 2x minus, what is that, 2. Is that right? Am I done? Why am I not done? What's wrong with that? Good, I can simplify. So what does it become? Good. Okay, so this is my GF of X. Now, part B asks me for, where am I? GF of X equals 2. Now, this is a little bit different to what I did before. Before, I said I wanted something like that. That's not what this says. What does this mean as opposed to this? It equals 2, right? So for this one, I had to substitute X as 2. But for this one, I'm told that the function, this function I just created, equals 2. So what I'm going to do is I'm going to bring this across as a multiplication. So I get 6 equals negative 2x minus 2. So then 0, or actually, what am I doing? I need to bring this across. I'm going to add 2. So 8 is negative 2x. So then negative 4 is x. See what I'm doing? So just be careful about the way that it's written, because you do not want to accidentally substitute x when they're actually giving you the value of the function, which traditionally we think of as y. All right, I'm going to do one more question, which is a bit harder. This next question combines what we've been doing here with functions and our quadratic stuff that we've been doing. Like I said, we do a lot of combining this year. It's no longer so isolationist. All right, so question 12. Actually, let's zoom in again. All right, question 12 says that f of x equals k minus 2x and g of x equals 2 over x. And I am being asked to find, let me turn the page and see. I am being asked to find the value of k for which fg of x equals x. Is that what it is? What? Fg of x equals x has 2 equal roots. So I am being asked to find a composite function when that function equals x, when are there 2 equal roots? So what is the value of k that makes that true? So first of all, let's deal with our composite function, right? So let's put everything together. Let's change color. All right, so I'm going to start with f, so k minus 2, and then my g function is 2 over x. So I now have this function here, but it has to equal x. Okay, that's what I got told. This function, which I've just got here, equals x. So k minus 4 over x equals x. Now, this looks like the last question on the test. K minus 4 over x minus x equals 0. What should I do with this? Times everything by x, right? I'm going to multiply this whole thing by x because I don't want fractions. So now I get kx minus 4 minus x squared, and now it's a quadratic, right? So I'm going to rewrite it just because that makes it easier for us to see. This is the normal order that we have it in. And now I want to know what values of k mean that I have two equal roots. What do I do there? Nope. Yeah, I need to use the discriminant, right? So I'm going to take this and find the discriminant. What does the discriminant need to equal? 0, because I need two equal roots, right? So just one point of intersection. So I'm going to do b squared, which is k, so k squared minus 4a, which is -1, times c, which is -4, and that has to equal 0. So that there's no need to do anything quadratic. We're just going to deal with our discriminant. So I get k squared minus 16 equals 0. So k squared equals 16. So k equals 4, is that right? Good, plus or minus 4. So these are the values of k. That means that this composite function has two equal roots. Okay, that's question 12. All right, I'm going to let you have a go at question 1, and then I will do 1b in a few minutes, but I'll just let you have a go first.